Good morning, everyone. Welcome to the Strategic Innovation Fund Round 2 Alpha Phase Show and Tell webinar. We'll just give it a couple of moments whilst the last few people join the webinar. Okay, let's get started then. My name is David Richardson. I'm Head of Innovation for the Strategic Innovation Fund. If you could skip on to the next slides, Chloe. Thank you all for joining today. Hopefully we're going to have some really invigorating and stimulating discussions on the back of these show and tell webinars. We've got a number of projects for you today, which are really working in the area of system resilience under extreme events, and really looking at how we maintain critical operation of our energy networks as we move through the energy transition, as well as all the other resilience factors that are being impacting the energy system in the coming years and decades. I'm just going to give a quick overview of the Strategic Innovation Fund, if we could skip on to the next slide. For anybody who's new to it, the Strategic Innovation Fund is a program that we deliver at UKRI in partnership with Ofgem. And we have the shared vision of making the UK a real global hub for energy innovation. And what that means is being able to accelerate the UK's transition to net zero at lowest cost to consumer, and really aim to be the fastest transitioning major economy in the world, whilst also capitalising on the economic opportunities of doing that and making UK the best place for energy businesses to really grow and scale. Cutting across all that is people, planet, and business. And it goes without saying that some of the things that we're really aiming to achieve is introduction of new products and services, which will help reduce costs, but also reduce carbon in our energy system, that we maintain and improve the resilience of our energy system, both for the people that use it, and also just so that we're able to connect the growing number of intermittent renewables and other low carbon technologies, whilst also leveraging this opportunity around business and commercial growth in the sector. Next slide, please, Chloe. And so far, this is round 2. We've actually got round 4 live, and our Call for Ideas competition will be opening soon for anybody who's interested in our latest innovation challenges. But as a quick reminder, the Strategic Innovation Fund is a £450 million fund over the RIIO-2 price control for the energy networks. It's an innovation stimulus which is paid for by consumers on their energy bills, and therefore we're looking at how we can return benefits back to those consumers who have made these investments. And it's really a process which follows a 3-phase cycle through discovery, where we're really looking at the problem and defining what the issue needing to be solved in is, before moving into alpha, which are larger 6-month-long projects. These are really looking at prototyping and solution development, whilst also testing it against that previously defined problem, before moving into the beta phase, which is the large-scale, multi-year, multi-million, nationally significant demonstration projects, which will operate in test environments or in real-world network environments as well. So this is a really exciting time because it's the first time that we've had all the energy networks involved in one round. And the first one, we didn't have the distribution network operators as well. And we're also in that transitionary period right between alpha, moving into beta, where the projects have done quite a lot of detailed work, have really honed their thinking around an area, and today are sharing with us what they think the best next steps for their projects are. We've got an early indication of benefits that we've achieved through the SIF so far, and these are still dependent on the beta projects being successful to deliver them, but we've got opportunities for huge cost savings to the consumer of potentially over 2.6 billion. And we've also got a very large carbon saving potential out of the SIF funded projects that have been funded so far. We've committed around 136 million of the programme, and we're expecting to commit close to the same this time round as these projects go through assessment in the next few months. If you could skip on, please, Chloe. So to quickly run through the agenda, we've got 6 projects for you this morning and running into early afternoon. As I said, these are all working around this area of system resilience and how do we operate the energy networks most effectively in the future. So they do have a lot of connected themes and areas. We hope that you'll all benefit from listening to each other's presentations as well. There will be a Q&A session after every presentation. So please drop your questions into the Q&A box and we'll pick them up in that session. Ask as many questions as possible. This is your chance this morning to really grill the projects on what they've been doing, why they've been doing it, and what their plans are for the next phase as well. So do make the most of the opportunity. If we could skip on, Chloe. And with no further ado, I'll hand over to the Scenarios for Extreme Events team. Jenna and Luke will be talking you through their project, which is looking at how we can classify different forms of really extreme events that might hit the energy system, such as cyber attacks, extreme weather events, economic shocks, and start to plan procedures and processes for responding to them as they come about on a very rare but very impactful basis. So over to you, Jenna and Nick.
Thank you. Good morning. So on the next slide, we just wanted to introduce ourselves. Oh, sorry, if we can just skip the next one as well. So my name's Jenna McGregor. I'm a resilience engineer at National Grid ESO.
And I'm Luke Edelston. I'm a senior consultant at Fraser Nash.
Okay. On the next slide, some of you may already be aware that this summer ESO is going to be moving out of the National Grid Group and transforming into the National Energy System Operator, otherwise known as NESO. NESO is an independent and public corporation, and with that, we're going to be getting a few new responsibilities, and that includes reporting on risks to industry and to security of supply. To help us with that, we've set up a new branch called the Resilience and Emergency Management Directorate. And one of their roles is going to be looking at industry resilience in order to inform policy and support decision-making. Key risks that we identify that could damage or disrupt the GB whole energy system are then going to be reported to government in an annual report called the Energy Resilience Assessment Report. Next slide, please. This report comprises of 3 activities, which we can already do. Firstly, we have to identify those risks, then we have to assess the likelihood and the impact of those risks, and finally, we need to make high-level recommendations on how to reduce either the duration or the number of consumers impacted. But this relies, can you go to the next slide, sorry. But this relies quite heavily on qualitative data. These risks are high impact, but they're very low probability, which means that they've either never happened or they haven't happened in recent memory. So although we'll be working with industry experts, it very much depends on their viewpoint. So the data is going to be very subjective. And gathering this data can be difficult at times and quite time consuming. And also because we want to have a broad view of electricity and gas, transmission and distribution, it's difficult from an expert perspective to get that sort of cross-sector view and go back and forth between the two. And that's really why we want a model. We want this model that we can input weather and non-weather scenarios into and get a numerical output of the number of consumers that are impacted, where they are, and how long they're going to be impacted. So next slide, please. So why is this something new? Well, we need a model that's going to operate at a high level. And that means we're not necessarily interested in how an asset might be affected by the scenario, but we're more interested in where assets are affected by different scenarios. So we need to have that sort of upper level, high level resolution. And one of the advantages of that is it means that we can run these scenarios relatively quickly and input slightly different parameters and get an output without having to wait or gather a lot of data for a prolonged period of time. We also have to have that ability for the networks to interact and for failures to cascade. And that cascade of failures has to happen from transmission to distribution, but also across sectors, from electricity to gas and back and forth as well. We also need our metrics to be consumer focused. We need to ensure that this can be understood by different stakeholders and have open and transparent conversations with industry and government. And we also need to be able to input weather and non-weather scenarios. These can look quite different, and we need a model that can handle both of them. So now I'm going to hand over to Luke.
Thanks, Jeanette. Next slide, please. So something we've developed through Discovery and Alpha is this risk assessment framework. And there's three main parts to this. The first is we use past data to inform stress event scenarios, and they themselves have a particular likelihood of happening. And as mentioned earlier, we're not just focusing on weather, but also focusing on other events, which could include cyber attacks, gas supply restrictions, and things like that. These are then input into our resilience model, which we've developed in alpha phase. And this predicts the outputs, the impacts to the consumers, and these are called resilience metrics, as Jenna mentioned earlier. So these are things like the number and duration of consumers disconnected, and we'll talk about more of these later. So what's interesting about this is the risk is normally modeled and is scoring from like 1 to 5 on an impact basis and a likelihood basis. And so this quantitative risk assessment allows us to track it over time and actually compare different scenarios as well as system configurations, which could be predicting things that are different in the future about the network, such as resilience measures that apply to the whole of GB. Next slide, please. So as I mentioned, we've developed a model within Alpha, which takes inputs from scenarios, and these can be any kinds of scenarios. So it's not limited to weather or anything like that. It can take any sort of input, and this takes in inputs of the asset data, what kinds of things are failing, and that feeds into the distribution and transmission network model that we have. In Alpha, we've done a smaller subset of GB, which is just the Northern Scottish network. And what this has allowed us to do is to get the information about high-level assets, the customer data, and feed that into an energy balancing model, which predicts the impacts. So these impacts, things like customer outages, vulnerable customers who disconnected, generation margin, and things like that. So why is this unique then? It's unique because we're able to model the interdependencies for the whole energy system. It models both gas and electricity and distribution and transmission networks. And what's really important is that this focuses on how consumers are affected by different scenarios. Next slide, please. So here we can see we have some indicative model results from our alpha phase model. And as I mentioned, this is focused on Scotland and is fed with dummy data to make it secure. So the scenario that we have is that we've got a loss of gas supply to consumers, and this is modeled on a realistic case study that did happen. In this case, the consumers switched to electricity-based heat and cooking where they could, for obvious reasons, and then this had the impact of increasing the load on the electricity system, which caused substation failures. So at the bottom right there, you can see that the model actually manages to see where the substations have exceeded their capacity and the load is increased past a certain amount. So the bigger the dot, the bigger the issue, basically. And so this leads to failures which are then modeled within the model And so then you get at the top right-hand figure, you can see how many consumers have been disconnected and an estimate of how many vulnerable consumers have been disconnected as well. So this is interesting because it's somewhat common to be able to model electricity impacts on the gas network, but it's been less common to do it the other way around and model gas supply failures and how that impacts the electricity network. So this is really interesting, again, because we're looking at these interdependencies. Next slide, please. So as you've seen, our model is able to model the interactions between gas and electricity, which is really, really interesting. And these impacts have been modeled, and the outputs are in terms of customer-focused resilience metrics, which Jenna will outline shortly. And we're very sure that this can be scaled to the GB, since the methodology takes real data in terms of where the assets are and things like that. So what are the next steps then? We're looking to further refine more scenario definitions, look at fragility curves and restoration curves and embed them within the model itself, and also look at different network configurations, which may reflect improvements to resilience on the network. Next slide, please.
Hopefully you can already tell that our focus is very much on understanding how our communities are impacted. And that's why we focused on having consumer metrics. So the size and the duration of any possible impacts can be really easily understood. And because our focus is on that societal impact, we wanted to make sure that we could break those consumer metrics down into types of consumer. So from the maps earlier, you will have seen that we have vulnerable persons on there. And in the next phase, we hope to break it down into essential services and how those might be impacted by loss of power. All of this, it helps us to have open conversations about what level of disruption is acceptable. And by comparing these metrics, we can ensure that our consumers have the consistent level of service, no matter where they are in GB. So it matches what their neighbour has, or it matches across the country. It shouldn't matter where you live. On the other hand of that, we can also identify areas where the impact is outside of that acceptable level. And that's where we can start to make recommendations to government on how to mitigate that, either through changing standards or investing in impact reduction measures. Next slide, please.
So we've tried to quantify what the benefits of this kind of approach are. Obviously, there's large uncertainties in how much financial benefit modeling the network and potential impacts to it, and then deciding which investments to make and how much of a difference they will make. However, we have tried to do this, and as I read in the report earlier, this is actually a conservative estimate, which is quite interesting. So what we've looked at is the yellow line is counterfactual, where there's no change in the impacts to the network and the outages that we have. And then we've got some different scenarios there, which look at whether you have fewer events or you have less severe events. And what's interesting is that traditional resilience measures and interventions are less impactful or are not that effective at actually mitigating extreme events. Instead, what we need to do is look at wide-scale GB network interventions as recommended in the literature. So this is something we'll be looking to do in the future as well. So as you can see on the right-hand side here, like I say, we've tried to estimate the sort of benefits of directing investments based on a modeling approach, rather than just making investments as business as usual basis. And what this has shown is it's likely to have savings of the order of over £100 million over 25 years. So we think this is obviously very worthwhile, and we're going to be trying to continue this in the future as well. Next slide, please.
So during this alpha stage, we've really set the basis for how the energy resilience assessment can be enhanced by having numerical information. So we've defined those extreme scenarios based on duration and the number of consumers impacted. We've been able to run weather and non-weather scenarios across a whole energy system, and that just took us a few minutes to do. And we've also developed consumer-focused metrics, as well as also being able to adjust our input parameters and see how impact can change if we just alter the starting conditions ever so slightly. And finally, we've also seen that we can compare risks, and that's going to help us in future prioritise our resilience recommendations. Next slide, please. So what happens next? Well, we are going to want to continue to build on this work, and we're going to be submitting our application for beta in next month, May 2024. And we want to ensure that we can expand the coverage that we've already got to across the whole of Great Britain. We also want to expand our catalogue of scenarios, so weather and non-weather scenarios, to build that up. We want to investigate how artificial intelligence can help us in those resilience assessments. And we want to continue, as Luke said earlier, to enhance the network modelling and look at those feedback loops between gas and electricity, and also some of the other dependent interactions like water and telecoms. So if you're able to support with this, we'd love for you to get in touch. Otherwise, on the next slide, please, I'd like to say thank you to everyone who's been involved in the project so far. Thank you very much. And any questions?
Thanks, Jenna. Thanks, Luke. We're just waiting for questions to come in ourselves. One of the disadvantages of being first is you do often have people being a little bit shy before the ice is broken. But I've got a couple of questions whilst we wait for them, if that's okay. So principally, are you looking at responses as interventions to these events, or is it also forward planning aspects like network topology or energy pathway decisions, which are part of the scope as well?
We're looking very proactive. So we see this as something that we will either be looking at the standards of those systems and see how we can influence those, make the recommendations to government. So, you know, system standards, but also any investment in those impact reduction measures. So could we put more standby generators, could we have more standby generators available in that area? Things like that, that we can then reduce the duration and therefore reduce that impact to consumers.
Mm-hmm. So there are interventions that you'd be making ahead of seeing some of these extreme events rather than being responsive when they do happen.
These are recommendations that we would be putting forward to government as suggested for how they would invest in future to prevent these risks happening. So these are all going in a report to government. The Secretary of State will see this in their annual energy resilience assessment report, and there'll be recommendations. And we'll have to look at, if you did this, if you put those extra impact reduction measures into place, how much are you going to reduce that impact by for that one scenario, but also could you see multiple scenarios? Are we going to see that this one tiny sort of, with this one investment in one location actually will help you against multiple different scenarios?
Got it. We've got a few other questions coming to the chat. So one from Andrew Howard saying, is the hundreds million in benefits over 20 full years a full cost benefit, as you did not mention the cost of the design to mitigate the risk?
I think I'd hand this over to Luke.
Yeah, well, I think the design is for the next phase, and people can look up what the limits of that is. And it would still be in the order of hundreds of millions, including the design of a model and implementation of that. And as Jenna's mentioned, this hopefully feeds into when ESO transitions into their next role. So it just kind of improves their decision making with quantitative risk assessments as well as qualitative risk assessments.
So essentially, when the full operational procedure and beta project is scoped, then that will be discounted against the overall cost benefits, but you expect it to still be a very high benefit case. We've got another one from an anonymous attendee saying, you've mentioned that you define extreme events by impact to customers. do you include climate change impacts as well, or more short-term events, e.g. storms?
So our plan is to look at these climate change related events and see how that translate into customer impact. It's very much, we understand about extreme weather and extreme storms that are coming through, but we can see that with this tool about how many consumers are going to be impacted, and therefore, again, what mitigations could we put in place? Do we need to change standards to make ourselves more resilient to slightly stronger winds? If windstorms are going to become more frequent or more extreme when they come across, that kind of thing. So we'll translate it into consumer impacts.
Got it. And one from Andrew Larkins. Thanks for a great presentation. How are you identifying new and emerging threats as we move to a smart grid with large-scale demand-side response?
We're always horizon scanning, and we'll always be looking out to build up our risk register. But a lot of it is what we're thinking about is those really extreme risks. So it's those high impact, low probabilities, and just focusing on those. If we can ensure that we have the right mitigations in place for those, then less extreme risks we should be able to handle as well. But it's always that horizon scanning and working with government and industry on what their key concerns are.
Yeah, I'd add to that as well. With what's informed that what we've looked at initially is obviously our skill sets, including people like Met Office within the team and Strathclyde. So we've obviously taken the wind scenario and analysed that in this phase. Equally, I think there's also an element of looking at existing literature. So things like the UK Risk Register, we've consulted that, and we've actually mirrored how we're going to do risk assessments based on that. So it's aligned with standard government policy and things like that. So everyone should be able to understand it and read across different government documents quite easily too. So and something we haven't really mentioned within this is that this is all part of will be part of an annual risk review. Jenna did mention the report, and part of that does involve subject matter expert looking at things and assigning what we need to look at and deciding which scenarios are the most important to look at. So it isn't just run a model and believe everything it says. There's a lot of really intelligent people in the background as well also looking at this.
We will always expect the model, just the output to be enhanced by the model, not to be solely based on the model. And experts' view is always going to be really important to us.
Yeah, I take those points. I think what people are kind of asking for is a little bit more specificity on what are seen as some of these extreme events that might be hitting the system. And for instance, that question, Jenna, not necessarily saying that those are small scale risk factors that might happen because of greater use of IoT devices, a more interconnected and digitalized system. Those could be quite large, even if they're caused by a lot of distributed assets. So would you be able to just touch a little bit more on what are the categorizations of events that are considered?
I'm sorry, I'm not sure I completely understand it, but we did break down, we went through the National Risk Register and we categorized the risks into like, were they natural hazards, were they cyber, were they physical, that kind of thing. Is that the sort of question you're asking? Sorry.
Yeah, exactly. So I think that question about demand side response could be cyber attacks which aren't to the core energy system, they're to people's edge devices which are in their houses, or not even cyber attacks. It just could be that there's a failure mode on EV charging or whatever.
Yeah, so I think the way the model is built is kind of scenario agnostic, meaning that it can take inputs of any sort of failures. And one we did do this time was a gas supply failure in one particular place. So that sort of, you could apply that kind of failure and say, what if this particular asset failed because of a cyber attack and so on. You can sort of scatter those sort of things around the network. And in terms of do we have a list and a register and things like that, that's been a part of both Discovery and Alpha to look at the UK Risk Register and see which of the kinds of events are relevant firstly, and then which are priorities and also which match our expertise as well. But it's really good being a part of the team we have because we've got such broad experience with people like Met Office, Strathclyde, and obviously ESO as well. So yeah, I think it's really positive.
So the next question you might have just covered there, but does the model take into account distributed generation and flexibility and how that could impact security of supply and resilience?
Yeah, so the current model of the north of Scotland takes in existing data of what the network looks like. It, in some cases, simplifies things to improve the speed of running the model. If you include everything in the model, you have to sort of cut it off somewhere. So this is a higher level model. It doesn't go down to every single little thing, but we make those decisions based on feedback from subject matter experts. So if we do make an assumption or a simplification, then we've got to make sure that actually makes sense. So these are within the modeling report we've got, and these should be uploaded. People can have a read of that as well, because there's a lot more information that I don't fully understand either, because I didn't do the modeling personally, but the modeling team did. So loads more out there.
Brilliant, great. We do have another couple of comments. Mark Granigan has kindly put in some links to some EPRI research projects, which might be related to some of the things you're working on. So do have a look at them. But thank you very much for the presentation today. Really interesting. We'll move on to the next one now, Chloe.
Thank you.
Which is CReDo Plus. In not a dissimilar vein, the CReDo Plus is really looking at how we build resilience across our whole infrastructure system, and particularly the interreactions between the energy system, things like our water system, telecoms, and other key critical national bits of infrastructure as well. So I won't give too much away because the team will know it much better than I do. So could I welcome James, Holly, and Elliot to give their presentation?
Yeah, thanks, David. So yeah, great. On to the next slide. Thank you. So hello, my name's James Daniel, and I'm an Innovation Project Manager at UK Power Networks. And with me, as David said, I've got Holly Hensler and Elliot Christou from Connected Places Catapult. Today, we're going to give you an overview of the CReDo Plus project, which is aiming to productize the Climate Resilience Demonstrator digital twin and moving it into a climate resilience decision optimizer platform, and all whilst keeping the CReDo acronym. I'm going to start by giving you an overview, and then Holly will tell you about the amazing work that we've been doing through Alpha with our consortium partners. And then Elliot is going to dive more into what the next steps look like for the beta phase. Next slide, please. So extreme weather is the biggest contributor to power cuts in the UK Power Networks region and has a detrimental effect to our 8.3 million customers. Climate change is expected to increase the severity and frequency of weather, and we're already seeing that with the likes of Arwen and Babet and the recent heat waves. And UK Power Networks customer service is absolutely critical to us, and we're always looking for ways to keep the impact to an absolute minimum. Now, there's a growing awareness also from government and research organisations that we have a lack of understanding of the cascading risk of our connected infrastructure systems. So we're developing CReDo to understand these infrastructure interdependencies within the energy system and with other parts of critical national infrastructure like communications and water. So I'm going to walk through a cartoon of how CReDo will help. Next slide, sorry. The cartoon starts with some electricity substations, water stations, and telecoms exchanges on a map. To keep the cartoon simple, we've left out other parts of the energy like gas, as well as other critical infrastructure. Now let's look at what happens if there is a storm that causes a 1 in 100 year flood. Click. Next, thank you. The flood knocks out this electricity asset, indicated by the red ring. Looking at this, naively, we might think that all the other assets are safe, but this picture doesn't tell the whole story, as we are not considering how the assets depend on each other. We need the connections that CReDo provides. Next slide, please. With CReDo, we can see the electricity, water, and telecoms connections, and how these services are supplied between the assets. This is enabled by CReDo's data sharing and digital twin technologies. Okay, so let's replay the flood in our CReDo view. Click, please. Now we can see the loss of power cascades through the whole system, knocking out all of the assets, meaning a loss of power, water, and comms to our customers. Next, let's look at a couple of options for how to increase resilience. Next slide, please. First, we can consider what happens if each network owner invests in flood defenses for their most critical assets. Great. Is this job done? We are resilient and customers will have all their services. But wait, what if there is another storm coming? Next slide, please. Now we have a 1 in 200-year storm with a bigger flood, and this overwhelms the defenses, once more causing the same cascade of failures. CReDo's connected decision intelligence can help planners find a more resilient solution. Next slide, please. With CReDo, we can look at the whole infrastructure system. We can identify that the most resilient investments is to build better defenses at the critical electricity site, which is lower cost and better for all our customers. Next slide, please. But in reality, the picture is far more complex than the cartoon that we've just stepped through. There are thousands of assets and connections, and decision makers need to consider different types of weather and over different time horizons to plan for our changing climate. CReDo's modeling and algorithms can handle that complexity. And through our user research, we've identified that resilience planning and risk reporting are the core use cases for CReDo's technology, the core use cases that CReDo's technology will enable. With CReDo, we'll keep the lights on at the lowest cost to our customers. Now, I'm going to hand over to Holly to talk about all the great work the team have been doing through the alpha phase. Next slide, please. Over to you, Holly.
Great, thank you, James. So throughout alpha, the technology development teams have been extending our cascading asset risk modeling approach to the extreme heat use case, as well as then prototyping the digital tools to build these models at scale, and then further developing the CReDo digital twin platform that connects all of that data and the models up for users. We've been thinking a lot about the product strategy and working on these benefits and doing lots and lots of engagement with different users and stakeholders. We've also adopted agile ways of working with 2-week sprints based on Scrum and are using digital Jira product management software. The added transparency has helped keep the work and dependencies on track across all of our different partners. For me, the greatest success has been really the introduction of demo playbacks and retrospectives, where all the team comes together to show off their work in progress in a space together without those silos, and then think about what we can do better. For me, as a product manager and a process nerd, I could talk a lot more about that, but I'm going to move on to talk about the tech. So next slide, please. What underpins a lot of CReDo is really understanding how assets are at risk and can fail from extreme weather. Once we know this, we can then propagate those failures through the network and understand the cascading risk, like in the cartoon that James showed. In earlier phases of CReDo, we've looked at flooding, and we want to test our approach to the emerging risk of extreme heat, which has very, very different risk mechanisms. So in discovery, we found that the historic data needed for machine learning doesn't actually always exist. Our solution to this was to elicit tacit knowledge from the subject matter experts, like the asset managers and engineers, and then we encode it directly into our risk models. Here you can see a simplified example that shows how a substation is at risk from a heat wave where temperatures exceed 42 degrees for 3 days. Through a series of interviews, the experts consider all the different risks that could ultimately lead to a supply interruption. For example, things like units overheating, termination faults, or wildfires. Next click, please. Then the experts provide judgments on the likelihood of these individual faults happening. Next click, please. If these faults happen, then how likely are they to interrupt the power supply? And they build those probabilities in there. Next click, please. And then CReDo's system-wide cascade model also provides the extra inputs from upstream connected assets as well. Next click, please. So we've developed models for grid, primary and secondary substations, as well as pole systems and transmission lines. Our Python code base then turns these into modular API services that can be used by CReDo and other systems. The interviews to create these were incredibly valuable, but this can take actually a lot of time. So we've been working on ways to scale the approach. Next slide, please. Here we've designed and prototyped a user-friendly tool that can dramatically speed up the creation of these models and help to digitize the expert knowledge on risk. Through the interface, users can easily build and document their own models, as well as distribute surveys across the organization so that experts can provide those judgments asynchronously without the need for expert elicitation. It is important to mention that there is a necessary element of training and upskilling for some of those network operator users, but our own risk modelers can see the benefits with this tool bring already. Next slide, please. Additionally, we've also continued working on the CReDo platform itself. So the digital twins knowledge graph and the data models have been extended to handle this new heat use case. And the new asset risk models are integrated so the users can understand those cascading floods from flooding and extreme heat together. On the screen here, you can see synthetic data for security reasons, but everything is operational on our secure servers with the real asset data. Next slide, please. So CReDo's expected benefits, really we're looking to lead improved understanding of dependencies, better planning and preparedness, and more accurate reporting. This will lead to higher overall system resilience, lower repair and restoration costs, and reduced customer interruptions and customer minutes lost. However, costing resilience is often challenging, so CReDo has integrated economic cost models and cost-benefit analysis tools to help with this. For flooding itself, we have found the benefit to cost ratios of over 50 relative to more generic investment approaches. When done properly, the scaling, when we scale this up to the UK across multiple industries and multiple weather types, we believe this will result in the benefits of billions of pounds. Next slide, please. Throughout the process, engagement has been crucial in evolving our thinking. So our Innovation Resilience Working Group has met 4 times with amazing participation and feedback from 13 network licensees and their SIF products. Some people are here today, so thank you for your support. Throughout the project, we've also carried out user research with UK power networks, asset managers, planners, engineers and decision makers, and have additionally explored use cases with National Grid energy system operator. Additionally to this, we've also had a really extensive industry and media interest in our project, as illustrated by some of the examples on our slide. So with that, I'm going to pass over to Elliot, who will share our thinking on the next step. Next slide, please.
Thanks, Holly. So as you've heard over this show and tell, with CReDo, our mission is to enable coordinated decision-making and efficient investment by understanding interdependencies and cascading risk across critical national infrastructure, so that together we can increase resilience to extreme weather and adapt to climate change. What makes CReDo unique is how it enables a whole system approach to risk modeling by connecting data across organizational boundaries so that our users know who they are dependent on and who depends on them. Now looking towards the beta phase, with the CReDo Plus project, our goal is to scale the CReDo technology across the energy sector. Through our user research, we've identified connected climate resilience investment planning and streamlining risk reporting as the 2 core use cases. And we want to commercialize a sustainable digital platform that will also enable further use cases into the future. So now I'm going to present a vision for how the components of the CReDo platform fit together. So next slide, please. Fundamental to CReDo is how we access and connect network and asset data across organizations. Our scale-out plan starts with the UK Power Networks asset base, where we've already made significant progress. And then we want to expand our user base to include other electricity and gas networks, and then capture interdependencies with other sectors like water and telecoms. To do this, we will establish secure data sharing infrastructure and legal frameworks. And at the heart of the platform is CReDo's dynamic knowledge graph technology that acts as the control center, orchestrating data, models, and other technologies with an interoperable microservices architecture. Next slide, please. We'll be bringing in weather data on flooding and heat, and we'll be using CReDo's extensibility to add in wind as a further use case and have an eye on other events in the future. Next slide, please. We'll continue developing our approach to risk modeling that you already heard about from Holly, but we don't want to reinvent the wheel. So we'll be trialing interoperability mechanisms to plug and play third-party models already held by network operators or their other innovation projects. And this is especially the case for things like wind. Next slide, please. We'll then model the interdependencies and cascade between networks in the energy system and with other sectors with our system-wide models. Next slide, please. But what's really crucial is that we operationalize all of this data and modeling capability. So we'll be co-designing a suite of decision intelligence tools with and for users to help them cost and invest in resilience over a range of weather scenarios and time horizons. And we'll be integrating risk and resilience metrics to streamline and unify reporting to decision makers, regulators, and government. Next slide, please. We'll be doing full-on user research and testing to develop user-centered applications so that users can visualize connectivity with map views, identify the best resilience strategies with decision views, and see the bigger picture with dashboard analytics views. Next slide, please. Through our research, we've identified different user types within network operators, including planners, asset managers, and engineers, and have generated buy-in with senior stakeholders. And naturally, there will be government and regulator users for the reporting use case. But safety and security are top priorities, so each user will have different role-based access permissions depending on their authorized use cases. Next slide, please. And finally, we will create mechanisms to share modeled data and insights back to user systems for further analysis or government systems for reporting. Now, it's really important to note that this isn't about CReDo or network operators owning or holding each other's data. It's about dressing each network operator's own asset base with information on cascading risk. Data will only ever be accessed on a need-to-know basis to protect the integrity of national infrastructure. Next slide, please. So that's our vision for the CReDo platform. In addition to this technology development, we'll be continuing with wide stakeholder engagement and working groups, as well as thinking about the product and route to market strategy, including things like commercialization, pricing and ownership models, and any regulatory change needed. Next slide, please. So on behalf of the CReDo Plus team, thank you for your time today, and please get in touch if you're interested in any further details or want to get involved. But I'll hand back now for questions. Thanks again.
Thank you very much. We have had a few questions come in. So the first one is, are there barriers to sharing investment and obligations for resilience across the regulated sector boundaries? And does this need different regulators to collaborate and develop a shared agreement for investment and risk management?
Yep, that's a very good question. The short answer is yes. I think one of the, if we wanted to go that whole way towards the vision of kind of cross-sector investment, then that will require regulatory change. But that's something with CReDo that we've been working on and thinking about over the time period. And I think it's about demonstrating the benefits to motivate why this is important.
So is that something you'd be facilitating as part of a beta project? I guess the first step is understanding where the costs and benefits manifest themselves through some sort of trial. But then a later phase could be working with regulators to improve collaboration and understand how investment in regulated sectors considers things outside of just their own sector, is it?
Yeah, exactly. So, we've, as Holly said, we've already done quite a bit of work costing the benefits of this. I think our primary use case is around how network operators themselves can create more resilience in their own system with awareness from other organizations and sectors they're connected with. It's probably easier to work within your own sector, so within energy, and we're going to be scaling out from there. But yeah, the kind of longer term is about facilitating those engagements and workshopping around how we can broaden this out across sectors, because obviously energy is regulated by one organization and water is regulated by another organization and telecoms by another. So it's about how do we connect to that top stage of government.
Got it. Yeah, thanks, Elliot. We've got a couple in the webinar chat from Luke Edelston from the previous presentation. What is the main challenge you see with scaling this to Great Britain?
So I guess I can answer this from the kind of tech point of view, and then maybe others can come in with other sides of this. So from the technology side, I think there's, we've presented this picture of the platform. There's naturally the security concerns, and we've been doing a lot of thinking within CReDo on how to do that data sharing, how to maintain ownership over your own data. That there are vulnerabilities there in connecting things up, so that needs to be done in a safe and secure way. Not sure if James or Holly want to come in with other views on this.
No, not really. I echo that, Elliot. I think that's probably the biggest area for challenge is in all of our engagement is probably one of the most frequently asked questions around how we're going to centrally manage or work with different critical national infrastructure data, but we have a plan for it and an approach. So I think we have appropriate mitigations in place to handle it.
And another question from Luke is, what are the forecasted financial benefits for your approach?
So we had a slide on this. So we have been looking at over the investment period up to, I think it's 2070, through the cost benefit analysis template. All of the modeling work has been done with the asset data that we have from UK Power Networks and other partners and our risk modeling. And we took that for the use case of flooding, and we calculated things like the direct costs from the flood to each asset, the cascading costs, so things like indirect costs of if there's an upstream loss of energy supply, what's the impact on that? We've thought about things like regulatory costs and other societal benefits, and we compared our use case of what CReDo's decision intelligence can find as like the optimized investments for the sort of investment amounts that UK Power Networks will use. And we compared that to different counterfactuals, like where the networks aren't connected up, like where there's more blanket and I guess less sophisticated approaches to where you're putting investments. And for that case, we're finding benefits in the hundreds of millions over that period, and then and that's just for like a part of the UK Power Networks asset base. So then, if you start to think about how you might scale that up to the UK, considering different types of network operators and how they're connected up, considering not just flooding, but looking at some of the extreme heat data and extreme heat predictions, and then wind and other types of risk vectors, then all these multiplicative effects get you towards benefits well into the billions, obviously assuming that everything's done correctly.
Yeah. See, those wider societal benefits, do they include things, for instance, like lost productivity because people aren't able to get to work because the power system is out or aren't able to work effectively? That kind of thing is
completely, yeah. So I guess on one side we've got the direct things from customer interruptions and customer minutes lost, which we can calculate directly in CReDo, knowing things about how many customers each each individual asset supplies to, or that its network supplies to. And then we're using economic metrics like willingness to pay from each regulator as a way to approximate that loss of economic surplus and how that affects productivity.
Great. I often think myself is when we look at energy pathways, we probably put too much focus on the lowest cost from a sort of levelized cost of energy perspective, and actually investing in things which might not be the cheapest option up front, but avoid some of these wider costs, might end up being far cheaper for the country as well. So it's great to hear you're thinking about that.
Yeah, that's it. Sorry, I'll just add
Sorry,
to
go
that
on.
because I think it's a really good point. That's kind of exactly the case. And costing resilience is hard, right? And there's this kind of multi-dimensional problem that you're trying to solve of like cost, resilience. Maybe you also want to include things like carbon emissions, and these are all different axes that you need to think about optimizing over, and what is your time horizon that you want it to be effective to.
Mm-hmm. Yeah, fascinating. I can see some sort of interactive tool sort of telling you just what factors you want to optimize for, and really making it more transparent that you might be getting a low cost option here, but you might be increasing your risk later down the line.
Completely.
Brilliant. Thank you very much. We'll finish there, but that was a brilliant kind of lead on from the scenarios from extreme events project, because you can certainly see where there's correlated parts of work there, whilst also focusing on quite distinct parts of the problem as well. So thank you very much for that. The next project is Trinity, which is looking at developing a control room simulator for operational control room operations in the distribution networks. So I'll hand straight over to the Trinity team to talk you through what they've been doing in their alpha phase.
Hi, yes. Next slide, please. Yes, hi. Thanks, David. Yeah, so my name is Nikolai Hooting. I'm an innovation project lead working for UK Power Networks on Trinity. And with me today, I've got Jack Ward from our control system automations team at UK Power Networks. And our partners are GE. I've got John McCartney on the call, PNDC, Kyle Jennett. And from Digital Catapult, we've got Carlos Carvajal. Next slide, please. Yeah, so what's Trinity looking at? So the problem basically is that networks are getting increasingly complex and therefore more complex to control with the net zero transition and deployment of low carbon technology. So as such, the role of the control room is also changing increasingly. So we've got uncertain levels of demand generation on the network, DSO capabilities that are being developed and introduced to the network. And on top of that, like we've just heard from CReDo, we've got increasing number of extreme weather events, for example, affecting the network as well. So we've got new operations and control systems being introduced to the control room to make sure they can deal with those changes. But that needs to be done in a way that is ensuring a safe and reliable operation of the network. So, for example, if you want to automate routines that we ideally want to do that after we've simulated and tested them extensively before we roll it out to the network. Also, that the training of control room staff needs to be more comprehensive and cover an increasingly complex range of scenarios. And also, ideally, that happens in a dedicated training environment. So in Trinity, in discovery phase, we found that SCADA-based simulators do not really offer the required functionality or flexibility or speed to be able to do those kind of simulations. So the solution that Trinity is looking at is to introduce a load flow-based control room simulator, which is fully integrated with the ADMS system and allows network scale simulations dealing with a large number of operational scenarios and complex network configurations. So the three application areas that we've got here for the network that we are looking at are, first of all, an environment to develop and test optimized operations. Second, as a training facility. and thirdly, as a sandbox environment for de-risking deployment of network innovation. So next slide, please. So in alpha phase, the main target was to test and validate the simulator and verify that it does have the maturity to be used as a platform upon which we can innovate during beta phase. So how did it look like from a project perspective? So UK Power Networks was the lead partner. So we provisioned the environment for the simulator to be deployed upon. And then the control system automation team performed acceptance testing for the use cases that were defined in the previous phase. GE deployed the prototype network simulator, both at UKPN and PNDC, and supported us with the testing of the and the validation of those use cases. PNDC then did some independent validation of the simulator and also prepared for offering a DNO agnostic test network in the simulator that can be used in beta phase for this kind of sandbox environment. So from discovery phase, we added new partners. So we had Digital Catapult joining us, who looked at the assessment of kind of integration options with A&M solutions, and also led some stakeholder engagement across the industry to inform what direction we would like Trinity to go in beta phase. And then SSEN, as the partner network, they provide a complementary network perspective on the user requirements. So I'll now hand over to John from GE to talk about the deployment of the simulator.
Yeah, if we could have the next slide, please, that'd be great. So the first thing we needed to do was to provision the infrastructure. And so we defined and documented what that was, and were then able to get that infrastructure provisioned at UKPN and PNDC, and actually within GE as well. Then what we did is we took the set of use cases that we developed during the discovery phase, and we incrementally were developing the additional capability that were required for that and deploying that out both within GE as well as down into UKPN and PNDC. What we discovered or defined as we went was to allow the use cases to be integrated into the simulator. There were certain pieces of network information that needed to be there. So, for example, the attributes for the network to allow the load flow engine to accurately predict what would happen, so it can then inject back into the system a realistic response, as well as also making sure that the sort of SCADA data is lined up with the network that is there. So we went through and we demoed these use cases as we developed them to UKPN and also to SSE, which then helped inform and take forward discussions about further use cases. Then we also captured videos of each of the use cases, which will be made available as part of the wrap-up of this. If we could have the next slide, please. Probably the sort of two key outputs from this were, as well as having a working simulator with a real-world DNO network model. Also, the other key output was the understanding around the data required for that, and how realistic that has to be, and what's needed for that. What we were able to do was take that data, apply it into a couple of different network models. One was the UKPN network model itself, as well as a DNO agnostic demonstration network model, which PNDC took on. So what I'll do now is maybe hand over to Jack to walk through some of the use cases and actually show some of the simulator working.
Yeah, thanks, John. Can we have the next slide, please? Yes, so we've been working with GE for the simulated deployment and also user acceptance testing. So for the alpha phase, the users were focused on the network operations, so myself within the control systems automation team, but also network control as well from a training point of view, and sort of the real focus is on how can you get power networks and other DNOs have a safe and reliable network, how can we improve on CIs and CML performance. So with the simulator, we went through the use cases and user requirements that were formulated in the discovery phase and that were put together to deliver the benefits. So they were sort of split into testing and training, and then sort of categorized further with application tools, integration, fault simulation, real-time network and protection schemes. So with GE, as John was saying, it was deployed on one of our environments, so we could then test the use cases and requirements. So we did initially have over 20 different use cases with requirements, which we went through. So the sort of the main output is that we had it on our simulated one of our licensed areas, SPN, so we could simulate that section of network, and then we went through the success of the user requirements and whether they met our targets. We also demonstrated it to control, so they could think how they use what they do for existing training, and then using the simulator as a potential tool to help train control engineers for the future, also refresh them, help them with new changes to the control system, and we also did a validation exercise with SSE as well. So we go on to the next slide. I've got two short videos that just sort of demonstrate that as part of Alpha, we're able to have a working simulator tool on one of our licensed areas. So this is briefly showing that it's very simple to do fault injection, and then the environment, because of the simulators based on the DPF, the load flow, it behaves electrically. So you'd get the analogs would change, get fault indicators, and then we can then use our automation responding to that fault, and then also having as another requirement being able to revert the network. So there's when we're testing new automation or training, it's sort of going through number of different steps. So being able to, just as a simple time saver, just to constantly always go back to how the network was at the beginning. So then we're always knowing going back to the same state before running another test or training scenario. Can we go to the next slide, please? And this is just another video, but showing a bit more of the integration, the interface that's there for the simulator, and being able to set up multiple different scenarios for trying to test and train different events, and it's relatively straightforward to go through with this interface, and then having the simulator on the screen next to it. So this was a requirement to have it user-friendly so it's not the expert knowledge of a control systems engineer, but actually also the network control engineer can use it as well, and other people within the wider business. Thank you very much. Next slide, I think it's PNDC.
Yeah, thanks for that, Jack. So I'm going to talk through the work package associated with the simulator validation. So we had 5 deliverables within this work package, and they're shown as the orange text on this slide. So I'm going to talk through each individually. So the validation plan was deciding and finalizing how we were going to validate the simulator at PNDC. So that involved the planning of that process, and we decided to implement a remote access option to access the simulator based around data sharing and network model preferences. We also agreed to schedule and run remote access sessions, access demonstrations with the CSA team. So that's Jack and the rest of his team. And then we finalized how we'd compare the data from the simulator to the validation environment that we deployed at PNDC. So the validation simulator at PNDC, we listed the data requirements for that simulator to UKPN, CSA team, and the GE development team. They provided all the data we required to set up that system, and then we set up that validation environment deployed at PNDC to be able to compare to the simulator. The third one, so we configured a server based on the GE requirements for the simulator that they were developing throughout the project. And then GE came on site to deploy that simulator at PNDC so that we could run it remotely. And that same simulator will be used going into the beta phase. The use case validation. So we ran prioritized use cases with the CSA team, and we decided to focus in on the protection associated use cases as we believed they would be the highest impact and provide most learning through the alpha phase. Finally, dissemination. So we presented our initial findings, project scope, and long-term ambitions for this project at the PNDC conference. And we're now scoping a dissemination event at PNDC around our focus areas that we're going to host later in the spring. Next slide, please. So this diagram just illustrates the validation activity in a more kind of graphical format. So on the left-hand side of the screen, you can see the development of the simulator. So GE provided access to the Power On simulator and deployed a demo network on our PNDC server. As John said, that implements a generic UK distribution network, so it's DNO agnostic, it's not specific to UKPN, which lends itself to being used in the beta phase with other DNO partners. As I said already, we chose to focus on protection-based use cases, looking at protection coordination and other scenarios. And then from that, running that simulator, we generated a host of use case data that we could then validate to ensure it was accurate or identify any problems. On the right-hand side was the development of the validation environment. So we took the same generic UK distribution network, the DNO agnostic one, and deployed that in the validation environment. Specifically, we chose to use DigSilent Power Factory to run those use cases. That then generated the same use case data, or at least the same use cases as the simulator, and we were able to compare like for like and identify where they differed and provide feedback for the report. Next slide, please. So the key outputs from the work in this work package, we deployed the base level simulator, which will lend itself to the beta phase plans. We fed back our analysis to identify bugs, areas of improvement, and additional functionality for future use case validation and development of the simulator. And we generated a validation report showing the performance of the simulator against the validation environment. Key challenges and lessons learned. We became aware early on of limitations to access the data, specifically confidential data on the UKPN network, but we found a workaround to that. We found it was useful to refine the focus of our validation, and we implemented that through daily stand-ups to accommodate updates throughout the project in relation to the simulator deployment, the network type, and new features being deployed. And finally, we identified there was value and impact of creating a completely independent test network for sandboxing with other DNOs moving forward. That's the last slide. I'll pass over to Carlos now.
Yes, thank you. And perhaps in the work that Digital Catapult did, we took a little bit of a step back and tried to understand the wider industry and how this solution could address some of the needs that we identify across different stakeholders in the industry energy. As you can see, we engage with plenty of actors, including MPG, Catapult Energy System, the DSO part of UK Power Networks, of course, GE for some validation, and SSEN as well. The literature review, which was one of the main milestones and deliverables of the work package, included the exploration of existing A&M solutions, emerging challenges and opportunities, and also included some information in the validation of the proposed solution and how we can position this solution in the market, and of course offer some market trends and recommendations. Some changes that occurred during the plan. Originally, we wanted to have a workshop where we bring all these people from the industry together and try to discuss some of the opportunities, some of the perceptions. However, due to challenges in the time and particularly the time of the year, We couldn't manage to get all the people in person for the workshop, so we pivoted into one-to-one industry interviews with all of these stakeholders, and a couple of times for some of them during 2 weeks, which we then finalized with a workshop, but only for the internal members. The main idea of the industry interviews was to review 3 research objectives. The first one was to validate the proposed solution as it was, investigate what are the opportunities and challenges for innovation in the space, and finally identify some adjacent application areas and opportunities for market adoption. The general output was that the simulation indeed is very well received and very much understood that it will generate enough value for the challenge that it is addressing. The study or this work package also offered a broader perspective on what are the potential application areas for the simulation without deviating too much from the core development. And finally, as part of the final workshop with the members, we also identify a few opportunities for following this project into the beta phase. Just to finalize the lesson learned, well, yes, it was very valuable to have all the people in the project together. Perhaps in the future we will try to have a similar workshop at an earlier stage in the development, but we also understand that for alpha it is quite a tight schedule, so it was very challenging. Another lesson was the time of the year. We learned that during that particular time, just before the financial years, there's also a couple of conferences, a couple of events that challenge the participation in person. But yeah, this is going to be taken into consideration for the next stage, hopefully. And yeah, I will pass on now to Nikolai to the last part of the presentation.
Great, thanks, Carlos. Yeah, so as you've just heard from the team, so in Alpha, we really demonstrated that the simulator is sort of mature enough as a platform, to use in beta. So for beta, we want to explore and prove that the simulator really is that valuable tool in those 3 areas listed here, the first 3 work streams. So we've got, use cases in all application areas in network optimization, automation, the control procedure optimization, that would include things like outage planning, and then really as a training facility, which is going to be a key focus. And across all those application areas, and that was one of the outputs of that workshop that Carlos described, is that there is a need to be able to simulate not only simple faults, but really whole events happening on the network. So one focus of beta is going to be to develop these kind of scenarios, and that could be things like non-network events, so the impact of extreme weather, cybersecurity incidents on the network, and recovering from those potentially very high impact scenarios. Simulating what does a black start look like for the network or a portion of the network, training on rotor disconnection, and also more towards the end of beta phase, we'll also be looking towards simulating the impact of some of the future energy scenarios that we might be seeing on the network. And across all of that runs the work that PNDC put the foundation in for during alpha phase is to really have that sandbox environment for grid technology to accelerate the rollout, de-risk the rollout, and also support other networks in deploying the simulator. We've discovered in alpha phase that data is critical, and anything we can do to accelerate rollout of that across the industry will be very valuable. So yeah, that's all from us. Thank you very much for listening.
Thank you very much. We're still waiting for some questions to come in, so please, any of the attendees, pop them in the Q&A now if you have any questions for the team. I've got a quick one with the previous presentations in mind. So with, for instance, the work that CReDo is doing to look at how other infrastructure sectors might interact and be impacted by weather events or other sort of disruptive events. Is there a roadmap for how you'd be able to integrate some of the data and products that a team like that is developing so that control room staff can simulate and start planning scenarios ahead of time?
Yeah, I think at the moment, we've got that sort of firmly on the first part of the beta roadmap is that development of the kind of scenario based simulation capability. So there we're looking at, first of all, to start with simple scenarios, being able to, probably simulate historic events that we've already seen on the network, and potentially simplified, randomized scenarios. But I think on the roadmap also, the ability to generate these kind of events. And I think when we start looking at, once we've got the base capability for being able to do these simplified scenarios, it's worth connecting with other projects in that space. So we've got CReDo, Predict for Resilience. I think Blade was a Black Start event that PNDC is involved. Black Start's event scenario type project that PNDC is involved with. So yeah, we will be looking at learnings from those projects throughout beta phase.
And with the use of this as a training environment as well, could you give us an idea of, from a sort of, do you see control room staff being a skills and capability area that needs expansion within the networks? Is there any change in how they work because of the change in the energy system we're looking at?
Yeah, it's getting the network is changing in the distribution. It has changed, and it will be changing rapidly with more and more generation on the network. As an example, but one of the things a simulator will give is the ability to have scenarios and being able to repeat them and replay them on a consistent basis. At the moment, the control engineers trying to train, they're kind of on the desk, but waiting for a fault to occur, so to speak, to then be able to react to it. Whereas a simulator will be able to have scenarios so that you'll be able to play them, go through 30 examples in a week, and so the control engineer gets that experience. I know it's not the same as being on a live network, but gets that experience on a repeatable basis, on the same for everyone, to be able to reduce that time and get that exposure to them before it's actually on the live network.
Yeah, I was wondering if at some point as well you can even use this as a tool to articulate like the real world impact of things to policymakers, to people developing technologies not on the network, that kind of thing.
Yes, yeah, exactly. Yeah, and one of the things Nick, I did touch on about looking at like historic events. So an event that say Storm Arwen or another event that perhaps involved a generator, and being able to replay that and have that as like a test example or a test scenario, to then show other people and share that knowledge of how the network behaved.
Awesome. Maybe to add on to that a wee bit as well, yeah, I think definitely you can show in future the impact of scenarios on the network and how that might impact users of the network. Things like black start or cold start events, David. And just to pin on to what Jack was saying, I think definitely the value of the simulator to train existing control room engineers is useful, but also in scenarios that are not really seen today because the network is becoming more complex. As well as more people are having to interact with the control room because of the needs of the control room, and external stakeholders are changing. So perhaps not just the control room engineers, but also peripheral users that now need to have at least an appreciation of what the control room does or what they perhaps need from the control room or can provide to the control room. So I think it goes wider than just batch training.
And if I can just add one last thing, is that as we discussed with John from GE, most of these tools already exist. So the simulation, as Nicola mentioned, it's mostly a platform where you can connect all these different sources of information, different sources of data, different ways of creating scenarios, and then potentially reduce the training and increasing the quality of training, going from 9 to 12 months to maybe a program that can be done in 6 months, for example, because you have a more structured approach to learning and training the different scenarios or different situations that you need to be prepared for during as a control engineer.
Yeah, great. You can really start to see some of those use cases come to life at this point, can't you? We will have to move on. If people, hold on, we've had one question come in from Andrew Howard saying, do you see, or where do you see a boundary between a network management tool moving towards a design tool, a network management tool moving towards a design tool, and a design tool increasing complexity towards a network modeling system tool?
If I can answer that, Nikolai, we identified as part of the industry interviews that there is also chances for forecasting flexibility and DSO to use the simulation capabilities to also create those scenarios and try to understand what are the best decisions that they can make, either to reinforce the network, to do more localized approach to black start. So there's a lot of potential, yes, and we're hoping to integrate that in the future, yes.
Well, we'll wrap it up there then. Thank you very much. Welcome back for the second half of this show and tell event. We'll be starting very quickly with a quick talk from Simon Hart on a competition he's running at UKRI at the moment. If we could flip on to the next slide. Over to you, Simon, if you'd like to introduce yourself.
Thanks, David. My name is Simon Hart, Head of Psychophysical Infrastructure and Digital Twins at Innovate UK. I'd like to just briefly mention a competition that we are running from my team, opening this morning with a briefing event on Thursday at 10 o'clock. Now, this competition is called Digital Twin Energy Grids, and it is a collaborative business-led competition for quite small projects ranging from sort of 100K to 300K and short duration projects between 6 and 12 months. Now, the competition specifically wants to look at what we have to do around the problems of seeing increasing demand for data across the energy system, increasing cyber threats, and the future proposals of using digital twins to help to model some of the grid and help us to provide some control strategies, or even actually used in situations where we can use them for testing simulation sandpits for doing experimental work. Now, this competition has come about for a number of reasons, but we want to try to tackle some of the very digital data and cybersecurity heavy projects that are maybe outside of the typical scope of SIF. We have a number of research projects that have been funded alongside this competition, and you can see their logos just down there on the left-hand side of the slide. We're very interested to see relatively short experimental projects where you want to try and do something to solve, let's say, data interoperability problems, about how you can secure things like operational technologies, maybe cybersecurity threat detection across the grids, and maybe looking at some of the future applications of how you could enable digital twins. The competition itself, we had a launch event last week. There's a QR code there at the top right-hand side that will take you to watch that back. Don't do it now, please, because we want to keep you on the webinar here. There's also a mural board there, which is a collaborative board that if you are looking for project partners or you've got a question or some other ideas you'd like to look at, there's some contributions from organizations on there already. And then lastly, bottom right-hand corner QR code, that's the official competitions page that on the typical innovateuk.gov.uk pages where you can see the full competition and register, particularly if you want to register for the briefing on Thursday. Happy to take any questions if there are. If not, please feel free to reach out through the briefing event on Thursday, or if you have any other comments, you can put them onto the mural board and the team will pick those up. Thanks very much.
Thank you very much, Simon. And just a request to everyone, obviously this closely relates to the themes that we're looking at this morning. If there are any partners or organisations that you know who would be interested in looking at this, do share it onwards as well and get them along to some of those events. Thanks a lot for joining us, Simon. We'll now move on to the next presentation, which is CommsConnect, which is really looking at the communications infrastructure that is needed to operate the energy system of the future. If I could hand over to Scott and Ross to give their presentation.
Thank you, David. Thank you for the introduction. Just been me speaking at the moment and Ross will be coming in with questions at the end. So if we could move on to the next slide, that'd be great. Great. So I'm Scott, I'm from UK Power Networks, and I'm really excited to present to you on CommsConnect, the project as a whole, our findings, and what our plans are for the next phase. So as part of this project, we had Nokia on board as a hardware OEM, we had PNDC, a research institute in the University of Strathclyde, and we had SSEN transmission to have a bit of a whole electricity network perspective, not just distribution, but also transmission. So we pop on to the next slide, please. Brilliant. So at a high level, we're 6 key things. We're going to be talking about the problem to be addressed, an overview of the project, then a detailed work package breakdown, so all of our work packages and what we identified from them, opportunities and potential benefits associated, how our thinking evolved, and then the next steps. So if we could move on to the next slide, big image, big question, key question that we were based the project on was what happened to mobile communications when the power goes out. So we might all have our own thoughts on that, but we just really want to increase the information interchange between both mobile networks and electricity networks to increase that information. So we all know what will happen when the power goes out. So next slide, please. So yes, the problem, electricity network operators, we utilize cellular networks to communicate, definitely have more resilient forms for the higher voltages, but as we go towards the lower voltages, we then do depend on networks such as public mobile networks. And then in recent years, this interdependency has been more and more exposed, and something that we always point towards is Storm Arwen, a report by Ofcom on that one mobile network operator had over 1,500 mobile mast site down, 130 of which were offline for more than 72 hours. So quite a big, quite a broad, quite an interesting problem. And next slide then, please. Brilliant. So CommsConnect, what is it? Well, we're looking to increase the resilience of cellular networks. How do we want to do that? Well, we want to do that by having a secure interchange between both the electrical and cellular network systems, so we can share data which would be beneficial to both parties, and always with an eye on keeping in mind new and innovative solutions with this data that we're getting access to. So if we pop on to the next slide then, please. Brilliant. So overarching everything, we want to enable increased systems visibility across both networks. So we had 3 main work packages. We had the first work package looking at stakeholder engagement and really refining the requirements. Then we had 2 main technical work packages. So how are we going to get this information and how are we going to bring it into both the systems? So in the big red box there, we had direct integration. So that was working, it's the idea of working directly with a cellular network to bring their information directly into electrical networks and vice versa. And then in the big blue box there, we had active monitoring, which was how do we deploy maybe sensors to our substation or asset locations to pick up on the network around us. So 2 separate things, but we'll go into that in more detail further on in the presentation. So work package 1 is what I'll be talking about next. So on the next slide, I'll take you through some of the stakeholder engagement that we had. So next slide, please. Brilliant, quite a busy slide. Not the only busy slide in this presentation, I'm afraid to say. We have lots of busy slides because lots of busy work done, but we had a great amount of stakeholder engagement and one-on-one sessions with multiple DNOs. We had operators of water and gas networks. We had interactions with Ofcom as well, the regulator for the mobile networks, as well as in-depth discussions with EE, Vodafone, other mobile network operators across the space. So really a key highlight of the project was getting all this useful and great interaction with all different stakeholders. And then just to point out on the right-hand side of the screen, there's been a number of events where we've given information about the project and we've had questions and input from different project partners. So that's been brilliant. Took part in CReDo Plus's working group on resilience, as well as had in-person events in London, in Glasgow and PNDC, and in Newcastle at the Risk and Resilience Day event. And there we are down the bottom, show and tell round 2 online today. So on to the next slide then, please. What is it that we learned from this in-depth stakeholder engagement? Well, on the left-hand side, the increased visibility of mobile and electrical network interdependencies, it definitely will help to benefit both parties as well as customers. So that's something which is really, really good. Middle there, if we have a more reliable communication network, that will really help to benefit the increased levels of communication anticipated by network assets going forward. And lastly, data sharing would be beneficial and would be possible, but it will be technically challenging to implement. So some of the work that we've done in the work package 2, direct integration, should help to bring this along. So next slide there, please. As part of work package 1, we had user needs. So this was when we went out to users from the electrical network perspective, what sort of information would they like to see brought into their systems? So as we move from left to right, first and foremost, they would like to see the way that the mobile network is set up, where all their mast sites are. And then at a high level, is a certain mast site resilient? Is there battery backup? Is there diesel generators on site? Because we could prioritize connecting to those sites. And then even the next step above that is if they did have battery backup and they switched from mains to battery, could we get a up-to-date signal on when they expect to retain connection? So is there half an hour remaining? Is there 15 minutes remaining, et cetera, et cetera? We move into the middle then, it's quite key for us to understand what mast sites our assets are connected to and really map that interdependence between the mobile network and the electrical network assets. And lastly, geospatial tool. So it's always nice to have something that you can actually look at, play around with, and understand things from, as well as being able to historically analyze where resilience might be best placed. So we don't want to say that everything needs to be backed up and super resilient, but we might be able to pinpoint where the best places for resilience are and ensure lowest whole systems cost for this resilience. So on to the next slide then, please, which is we'll take a pause for breath. We'll say that's work package 1 completed and run through. Work package 2, I've flagged with a big red box, but that's going to be our direct integration. And that's how do we look at trying to model this information sharing between mobile networks and electricity network systems. So I'll take a little pause for breath, but we'll move on to the next slide then, please. Brilliant. Okay, this is probably the busiest slide that I was referring to, but a busy slide, hopefully a fun slide, hopefully an informative slide. So this is looking at the physical installation of PNDC. So what we did is, if you look at that diagram, top right, we made a mock scenario. So we made a mock mobile network. So we have our electrical assets on the left-hand side connected through to this mock mobile network, which was made up of real Nokia OEM parts, a mobile network OEM. And what we were able to do was we were able to pull information such as, so you can see in that blue box there, the device is connected on which mobile mast, as well as if there was a failure of power, the percentage battery remaining on that mast site, that mock mast site. So we pull that into all the different parties in the electrical network who would be interested in seeing this sort of information. And also something key, which came from our discussions with the mobile networks, is that they would like to have some sight of some of the electrical network information, some of the way that their masts are connected, or the estimated time for restoration if there is an outage at one of their mast sites. So all really key, all really cool. Nice example. Oh, I think there's a bit of feedback there on the mic from David Gregory. Yep, it's brilliant. So we'll move on to the next slide then, please. Great. So then this was just to wrap up on that direct integration. We just had that PNDC event. So we got in the room a whole lot of different representatives from across the industry to have some really nice presentations and interactions and discussions. We were also able to show them around the installation site. And yeah, it was great. Everyone getting their hard hats on and their high vises on and getting to see each other in person was brilliant. But on the right-hand side of the screen there, you can see a representative current situation, so more of a reactive situation where we can see a number of electrical network assets and their status, yes, no, can we connect to it, can we see it? And one there being red, we're kind of left thinking, where's the issue, what's the problem? We need more information here. So if we click on the next, there should be an animation. Yep, so this is sort of the solution that we're proposing, and hopefully it makes sense at a high level, but that you'd be able to see of which of the electrical network assets, which mast they're currently connected to, and if there was an event such as a loss of mains power, how long you'd still be able to communicate with that asset. I think, Fabian, you have your mic on there, might be a bit of noise coming through. Right, next slide then, please. That sums up the direct integration, and what that allowed us to do is when we spoke to mobile networks, we could say we can bring this sort of information in through to the electrical network systems and vice versa. Now looking at the active monitoring bit, so this was kind of a different technical approach to getting the same sort of information into the system, but less talking directly with mobile networks and more looking at our own assets, our own devices. So if we move on to the next slide then, please. Brilliant. Yeah. So the main ask was, could we deploy a sensor into our substations that would allow us to pick up on these health and status of mobile networks around us? And what we actually did was we went one step back and we said, if we look at the mobile routers that are currently deployed, is there a way of writing a piece of code onto those routers which would allow us to monitor the health and status of mobile networks around us? And what my colleague and Ross from PNDC was able to do is he was able to take them apart, and he saw that they used the same chip, and he wrote a script on that chip which would allow it to scan the networks around it and report on exemption when changes happened. One key challenge from the business was that these routers are really important for the primary function, which is SCADA communications. So Ross was able to write a prioritization algorithm, which allowed for SCADA communications to always be prioritized and network scans to only happen in the background, which was really, really good. And it was a great outcome. So the next slide then, please. This should just give you a graphic of the sort of map which we would then be able to build up, which Ross was able to make in reality. But this is just the sort of information. If we had all of these devices, so all the blue dots, we could pull a really nice, accurate picture of the health and status of mobile networks and how they're connected. So not only which devices which masts our devices are connected to, but then the mast showing there all of the devices that it's currently supplying its communications to. So move on to the next slide then, please. Just to look at some of the potential benefits for the overall project. I'm acutely aware of time as well. I'm trying to make sure that I hit the 15-minute mark. So at a very high level, if we look at the short-term benefits, it might allow us to support communications with vulnerable customers, because we might know where there might be network black spots because there are certain telecoms networks down. For instance, a mobile network operator can figure out which of their devices are affected by an internal fault at their location, or whether there might be an issue with the electricity supplied to a mast. In the middle term, that will allow for better coordination of timeframes for restoration. So a mobile network operator might be able to send crews to fix an internal problem, or they might know where to send tow-to-site generation if they have more information coming through from the electrical network side. Also, it'll allow us to maybe see where there might be particular areas in the field where field staff might be able to ring into control room because they don't have reception. In the longer term, we'll be able to do a historic analysis on mobile network reliability and really figure out which of our key sites should be connected where, and where we could work together to try and have resilience installed at different mast locations. All of this being more confidence in the ecosystem integration and really working better together as operators. So next slide there, please. Bring us on to how our thinking of the project has evolved. So one really nice key learning from the project was that we found that cellular network operators were willing to share information, which was really good, positive, and it would have benefits for both parties. So that's a really nice output. In the middle there, I think one thing that we point towards is having a physical installation in 6 months is great, but it was definitely ambitious. So I think having the physical installation gave us credibility when we were speaking with our external stakeholders, but it did put a lot of pressure on us in terms of getting everything closed out in the 6-month window. And it did allow us to have a lot of lessons on integrations learned as well. And lastly, on the right-hand side there, we can see that from work package 3, the active network monitoring, there are a number of potential applications, and PNDC were able to address the challenges on the primary use case of those devices. So we'd like to see about further testing and possible field trial for the next phase. So onto the last slide then, please, of the presentation. Cool. I could take a breath. I think I'm hopefully going to hit it on time, about a minute and a half left. Plans for what's next. So there's been strong support throughout the whole project for this project, and we look to continue to work together. We've had good interactions with DNOs, transmission network operators, and other sectors, and we have specific requirements for all that we'd like to further flesh out through further engagement. We'd like to continue moving this project forward under NIA funding, with UK Power Networks as the leading party. So at a very, very, very high level, the flow of this project would be, firstly, information sharing and integration. So getting those data sharing agreements set up with mobile network operators and getting the base level information into systems before we then move towards more proactive and intelligent information sharing. So the likes of battery percentage remaining sort of messages and which devices are connected to which mass, as well as some information being fed back maybe on estimated times of restoration for mobile mass sites. And then lastly, working together will give us hopefully a more coordinated and faster approach towards restoration. So I think we're just slightly under time, if anything. I've probably rushed myself a little bit, but I think the last slide is then on to questions, and very happy to take anything from the crowd.
Brilliant. Thanks very much, Scott. Just for questions to come in, but do give them a moment or two. I've got one whilst we're waiting.
Yep.
Do you know what proportion of mast outages or telecoms issues related to mass is because of power outages?
We actually, so that question would be, how often is it an internal, how often is it something internal to do with the operator themselves, and how often is it to do with the power not being? Yep.
Exactly, yeah.
I think Ross, you pointed towards some information on that. You had some statistics, not to put you on the spot. Maybe you don't. If you don't, that's no problem.
Yes, so how it's broken down is basically a hardware fault or an electrical fault, and that represents about half of the mobile network outages.
Thank you very much, Ross. I knew you had that information to hand. Thank you for asking. Thank you for coming in and saving the day.
So, sorry, does that mean that half of them are power system outages which are causing them?
No, half of telecoms outages are due to power failures of the power network providing the telecoms network.
Right, got it. Okay. Yeah, because I was just wondering, because presumably you'd be able to identify faults when it wasn't the power system's fault as well, which is good for having a greater connected infrastructure. But then it kind of feels like you're providing a service to the telecom sector, and to what extent is it UKPN's job to do their system monitoring for them as well, I guess.
So the main benefit is kind of the power sector requires communication, and they want the most cost-effective communication system possible. So if the alternative is providing a bit of battery backup to a telecoms mast, so that becomes as resilient as using VSAT or BGAN, that may be a more cost-effective strategy. So that's kind of the thinking that we're going around. But deploying a battery backup in the event of a power failure every mast is also quite cost-effective. So we found that through increased coordination, we can basically prioritize sort of sending certain generators to certain sites. So if there's one particular site that requires, has, I don't know, 3 hours worth of battery backup, and it's been sent a generator, if there's another one which has only got 5 minutes of battery backup and it hasn't been sent a generator, it might be a better idea to send the generator to the one that's going to leave in 5 minutes.
Yeah, okay, got it. Simon, you've got a question. I think you should be able to come off mute.
Thanks. I believe this project was linked to the CReDo demonstrator. Is that correct?
But we're working closely and had been touching in with them. But yeah, I think we're looking more at a minute by minute or kind of a real world, real life timeline, and maybe CReDo was looking at a more. So they were looking at the climate effects and then maybe the interdependencies, like mapping ahead of time. So they're pulling information from asset experts about how all the systems are intertwined and what will happen in the future. Whereas we were kind of looking at that real-time interaction between the two systems. Yeah, so there's maybe a difference in the time frames, but separate projects.
So
and they were considering different vectors as well. We were primarily looking at the interdependence just between mobile and electrical networks.
Got it. Okay. There is some areas of work going on with the National Underground Asset Register, who, yeah, I think it's looking to see what more could be done about trying to get this kind of data exchange done more real time. So yeah, it looks like a really interesting area of development.
Very much, Simon. Appreciate that.
Thanks, Simon. Scott, we do have one of question in the Q&A. Does the trend of moving away from diesel gen sets for phone masts to tech like batteries or fuel cells helps meet sustainability targets of telcos relevant for the project?
Okay, that's an interesting question. I don't know. I suppose probably the way that I would read that is maybe with the likes of a battery, you mightn't have as much capacity. You mightn't have the ability to go back to site if it's a very long outage. With a diesel genset, one of the primary benefits is that you could keep visiting with a Bowser and you could fill it up. But then if it's a very long outage with a battery set, then you can't do that. It would be one that we'd have to go to the telcos to discuss with them. But I know they, like us, would be moving away from diesel gensets and more towards either hybrids or solely battery systems. And I suppose maybe the question there is on cost, and then cost for long-term backup. Ross is going to come in.
One of the other areas is, of course, so in Finland, they've got the idea of flexibility markets connected up with mobile networks. So because there is battery backups, lithium-ion battery backups at particular mass sites, they're able to participate in local flexibility. And then only when there is an outage, then they would use that power themselves. The rest of the time, they can sort of regulate that battery up and down depending on local constraints. The other consideration is weight and complexity of getting to some of these mass sites. So similar to the electrical network, there's a wide diversity of assets in the telecoms network. Some are out in the middle of a field, and it's quite easy to pull up a diesel generator to that. But others, particularly in large cities, are mounted on rooftops, and it can be very difficult to get a generator up there. And the weight considerations as well of installing a large amount of battery backups to those particular sites could be quite prohibitively expensive or challenging. So that's why sort of having a more coordinated approach. And the other thing that's worth mentioning is automatic power restoration systems such as APRS that UKPN deploys. It requires that communication in order to automatically restore power to their customers. But in the event of a power outage which then leads to a communication outage, the communication is lost very suddenly, and therefore they're not able to run those automatic power restoration algorithms. And where even if they're given a little bit of warning, say 3 minutes warning, but you will lose power to communication with all of these assets, that automatic power restoration algorithm can run and then restore customers back on supply.
Super, very thorough answer. We've got no more questions that have come in now, so we'll move on to the next project. But thank you very much, and good luck with the Network Innovation Allowance phase of the project.
Thank you very much.
So moving on, we've now got Insights, which is really looking at use of telemetry and simulation on the power networks. So I'll hand over to SSE Transmission and their team to talk you through the project. Who's kicking us off?
Sorry, so can you hear me now?
Yeah.
So, thank you, David. Thanks for the introduction. Yeah, first of all, we'll go with just with brief introductions. So I'm Jonathan Powell. I'm part of the innovation team at SSEN Transmission. I'll hand you over to Fabian.
I'm Fabian Moore. I work for the HVDC Centre, which is owned by SSEN Transmission. I'll introduce the other two. They'll join us later on, which is Kevin Cowell from the University of Strathclyde and also David Gregory from the ESO. Next slide, please. Next slide. Yeah, so talking about the Insight project, which is about trying to provide measurement and insight to what's happening with inverter-based oscillations. So with net zero, we're transitioning to new types of generation, and these new types of generation have new forms of oscillation that are occurring. So basically renewable energy sources such as wind and solar interfaced using inverters and power electronics, and they have different dynamic behavior to fossil fuel-based synchronous generators, and inverter-based resources, or IBRs, can interact with each other in ways that are difficult to predict or anticipate, and these cause oscillations on the grid. And these kind of oscillations have been experienced on power systems worldwide, including in the UK, and they have the potential to reduce systems reliability, cause equipment to maloperate, or in extreme cases become damaged. So I want to make sure that we can manage these issues. So what do we need to manage these? So we want visualization and analysis tools that will help network operators be alerted to identify and locate these oscillations so they can understand what oscillation modes are happening on the system in real time. And also we want control and mitigation tools to help network operators to take appropriate actions to mitigate oscillations when they occur. Next slide, please.
Okay, so here's a project overview. So with Insight, we really wanted to build upon knowledge of previous projects and previous learnings, and because we know there has been work done in this across a number of networks, particularly obviously ESO, who are a partner within the project. And we also wanted to develop new modeling and simulation techniques to better understand the challenges of new types of oscillations and how we can detect those and address them in the network design. And I suppose our philosophy was, in terms of oscillation management, was to monitor, detect, interpret, and mitigate those oscillations. A key part of developing the solution was really, as I mentioned, building upon innovative projects. So as part of the work that we carried out, we identified key projects and engaged with those both through discovery and into offer, and that'll be spoken about a little bit later on. And some of the areas that we kind of focused on was modeling simulation of IBRs, particularly the rich networks and some power system oscillations with the increasing, obviously, penetration of renewables. We spoke with a number of technology solution providers during the project to understand their capabilities and what their current state of the art was for mitigating oscillations. So if we move on to the next slide.
Good afternoon. Good afternoon. So I'm going to just give a brief overview of what our sort of view on the user needs. So we split this down into kind of what the network operator and owners would think, or how we think about those, and then also kind of the eventual end users and any potential solutions as well. So for ourselves as a system operator in ESO, we think how such a project could enhance the system operation operability, and also how we can think about reducing balancing costs as well, because with recent events we've seen on the transmission system, we've had to sort of take commercial actions in order to try and mitigate oscillation, similar sort of events that have been investigated here. For the transmission owners, so for network owners, think about how we can improve system performance and the overall reliability of their systems. And then we come down to sort of the end users, so those who are going to actually be using the system in the end. I mean, this is more sort of like for future stage of the project. So it'll be aimed at providing information to control room staff. So thinking about how we alert events to users, and kind of what it's actually going to, what information is going to present to them, and what the sort of the user interface might look like. Let's say that's kind of once we have a viable system in place. And then for any sort of potential solutions, we part of the project was really to think about, providing a test bed architecture which we can use or a potential solution providing use to demonstrate their solutions to this particular project. So, next slide, please.
I guess the approach to the problem had several elements. First one was trying to improve our understanding of the causes of RBR-based oscillations. So to do that, we've just kind of done some work for us on oscillation events, modeling and simulating them. So they'll talk about that a bit later. We've also looked at understanding the monitoring capability on the transmission network. So colleague Jacob is not with us, has been leading the work package and looking at the roadmap. So it's monitoring roadmap. So it's kind of looking at what capability we have at the moment and where existing plans are taking us with monitoring outside of insights, just to work out where we fit. And also we want to understand the availability of potential solutions. So we've been engaging with stakeholders and technology providers, and that's been led by the ESO. And the last part is obviously, does a solution provide value for money? Jonathan's been leading the bit on cost-benefit analysis and developing a sort of cost basis of what we need to do as a solution. Next slide.
Okay, so I'm going to talk about work package 2. So it's about engagement with stakeholders. So, I mean, broadly speaking, this work package really built on the work on the output from the discovery phase, which in that phase was led by the HVDC Centre. So, we're looking at, which was a targeted questionnaire, and we mainly sort of targeted those who'd expressed an interest in future involvement in this project through a discovery phase. And then on top of that, we sort of had a two-stage approach. So as Jonathan mentioned, we wanted to have a look at what the sort of the current best practice in terms of innovation for oscillation detection and mitigation was. So that was an area that we looked at. So we had a knowledge share session with various sort of projects that are ongoing in that space at the moment. And then to engage with potential suppliers, we had held some targeted webinars to disseminate progress on the project and to understand kind of what interest there was in carrying on with engagement or sort of interest in this project to go forward. And as a result of those webinars, we held one-to-one sessions with various interested parties, which sort of understand, you know, what products and solutions and what they have and kind of their readiness to meet the needs of the project, and then again to understand kind of exactly how they might want to participate in future stages of the project as we go forward. So on to the next slide, please.
Hi, good afternoon, everyone. I'm Kevin Cable from the University of Strathclyde, and today I'll briefly summarize the findings of Work Package 3, which was the modeling and simulation studies. So this work package can be broken down into three main areas. In the first stage, we aim to understand and replicate the oscillations. So that was done via analytical modeling of the oscillation mechanism, and that went hand in hand with the development of a test network that was based on an actual portion of the Scottish network. We used this test network to perform several simulated case studies to simulate different oscillation scenarios. In the next phase, we took these simulated oscillations and passed it through some measurement algorithms that are typically used in the real world. So the light blue box shows phasor measurements, which are typically streamed in real time and synchronized over a wide area. The yellow box shows waveform measurements, which are not typically used in real time. They tend to be triggered fault recorders. Looking at the frequency spectrum of the two measurements, we see that the traditional phasor measurements can miss some of the underlying dynamics. And so we can conclude that perhaps we may need to utilize some waveform measurements. Finally, we looked at some oscillation source location methods available in the literature. Again, the light blue box shows the dissipating energy flow method, which is based on traditional synchronous dynamics, as well as traditional phasor measurements. We see that when it is applied to the emerging type of oscillations, the results can be difficult to interpret. For example, the blue trace shows that initially it's not a source, and then it eventually becomes a source. Comparing this to the yellow box, we have a waveform-based method, which uses oscillation power. And we see that it identifies all the waveforms as a potential oscillation source. Comparing these two boxes, we see that it's quite challenging to interpret the oscillation. Next slide, please. So the key findings from this work package, in terms of the modeling, we realized that we want to further develop this modeling to be more realistic, and that needs more detailed analytical modeling and an expansion of the test network. In terms of the analysis, traditional measurements like phasors have limitations. Increasing the reporting rate or looking at new forms of measurement from waveforms may better characterize these oscillation mechanisms. And finally, oscillation location methods that are based on traditional dynamics and traditional measurements can be unreliable and inconsistent when monitoring emerging oscillations. That's it for this work package. Thank you. Next slide, please.
So in terms of work package 4, this was led by SSEN Transmission, and my colleague Jacob Kelly, but it reviewed the state of system monitoring in the north of Scotland on the SSEN Transmission network and what was happening in the next 5 years over the next 5-year period, and just to provide visibility of what kind of monitoring data would be available without any specific device installation for the Insight project, just to work out what we're going to have access to anyway. And also looked at industry codes and standards that apply to TOs to make sure that we're covering what we need to cover, and also propose some next steps. So just a couple of pictures of some of the things that we looked at. On the bottom left, there's an overview of what proportion of sites at different voltages on the network have PMUs installed or have digital fault recorders installed. So there's a picture now where 100% of all sites have PMUs or digital fault recorders, but much less coverage at the lower voltages. And then there's a 2030 picture, and you can see that there's a plan to deploy more monitoring on the lower voltages. And on the right-hand side there's a picture which is, I guess, some of our proposed next steps. So to develop the solution, if we can get a good testbed model with the help of work from Strathclyde of developing oscillation test cases with IBRs oscillating on a realistic network, we can then interface this either via comms or via analog and digital hardware to equipment under test with a real-time simulator. And then in this environment with sort of known test cases where we know what the answers, what's oscillating with what, we can then see whether supplier sort of led solutions can actually detect what we think the answer is. So that's what work package 4 has been looking at. Next slide.
Okay, so the potential benefits for the consumer, they're both financial and environmental. It kind of goes hand in hand really with obviously the drive towards net zero, and this technology can facilitating the more I suppose strengthening the robustness of the network. So there's a number of benefits that we identified through doing a financial analysis, and one of them is the improvement in system operability, and that's because in the event of an oscillation occurring on a network, typically what happens now is power is either kind of tempered back, reduced, or high carbon energy sources are put in to replace until the problem has been resolved. But with Insight, we'll be able to ensure that these oscillations can be detected and managed without the need to bring in high carbon sources or restrict the energy output of the network. There's also a kind of a knock-on benefit of it reduces the risk of shutdowns in the network, and that's both locally or across the network as a whole. So potentially resulting in a black stop being necessary. And kind of linked with that is because a lot of power electronics is used in the network, there's a risk of damage to equipment and plants. And with more greater control on this through the management of oscillations, then potential damage can be mitigated to an extent. And we've determined the annual saving to be approaching 30 million. And this this is estimated over the T3 period, and it's kind of split into three main elements. One is the balancing mechanism, which is a mechanism for running the network. So that 25.5 million represents 1% of the total cost, which is 2.5 billion. And then there's cost reductions associated with localized blackouts and across locally, and obviously on a bigger scale across the entire network. And they're kind of conservative numbers, but I can provide more information that should, if anyone wishes to have that. So if we go on to the next slide, please. Oh, you're on mute there.
I'm muting myself, but the host keeps muting me. Yeah, how findings informing the future direction. So we've decided not to submit a beta round 2 application, and I think this is mainly because it's sort of the state of the technology and the state of our understanding, really. So existing measurements and analysis methods for low frequency oscillations are proving to be a bit insufficient for RBR-based oscillations. And although there are solutions provided by technology providers, they're not really mature or tailored to these RBR-based oscillations. And we think we need to do a bit more homework, really, before we can pursue a beta or progress the project with procuring devices and installing them. So we want to work with simulation analysis tools to understand the problem in more depth, and we want to work with technology providers to develop sort of new solutions. So we're planning to submit a plan and execute an NIA project, so sort of over the next 18 months, 2 years, and then I think potentially make a beta application back in 2026 when we sort of know what we want to do a bit more and have a clear idea of how to solve these problems. So I think alpha phase has unlocked some of the priorities moving forward. So I think we know some of the things we want to do in the NI project that we wouldn't have known with this work in alpha phase. Next slide, please.
Okay, so this kind of really kind of follows on directly from the previous slide and just kind of gives an indication of what we're going to be doing in the short term. I mean, we'll be doing those first three things in parallel. We'll be developing the project for NIA, ideally starting the latter part of this year. Engage with other transmission operators. We've already spoken with Scottish Power and they're interested. So, but we're keen to get involved as well. So we'll have some discussions with them. Build upon the relationships we developed with the technology providers during the alpha phase and kind of maintain those discussions to ensure that they can be taken along the journey, and then towards the NI project or during the NI project we'll obviously kind of hone in on a particular solution that we want to take beyond that stage. And I think a big part of it, which kind of incorporates all the work that we're doing, is we're keen to obviously communicate what we're doing through various events, posters, and potentially putting a publication out there based on particularly the results of the simulation work. So that's really what we've got to say as a project. So if you go to the next slide, please. We're thank you for your time, and we're happy to take any questions.
Thank you very much. We do have a few lined up. So the first question is, have you looked at how other countries with high IBR penetrations in their current energy mix measure and dampen these type of oscillations currently?
Yes. Part of the project was in the discovery phase. We put a questionnaire out which included a number of people we knew had oscillations, and we got a lot of feedback from those other utilities about how they're attempting to solve these problems. And I think also through the work that David Gregory led from the ESO led in this project, looking at what other sort of innovation and research projects are in this area, because InSight isn't the only project looking to these kinds of oscillations. So we're trying to make sure that we don't duplicate other work and make sure we're finding a sort of solution that's useful to people. But we have looked at it, and we're aware that plenty of other, this problem is an international problem. Other people have experienced these oscillations, and I think all trying to develop solutions that will help.
I've got a question following on. because maybe there is some insight from other countries. So it's my understanding that actually, I think one of your diagrams sort of indicated there's almost a binary stable system configuration and then one with oscillations. But actually, we found that a degree of oscillation is tolerated within the system. Do you have any idea of like ranges and resilience that's already embedded in?
Well, I guess perhaps one similarity would be to have some kind of limits like harmonic emission limits or something like that. But I think, yeah, and I'm not quite sure what level is tolerable, not tolerable, because how linear and scalable it is. If you're getting a small oscillation, are you showing that you're close to a larger oscillation if some condition slightly changes, some operating point changes? So I think we're probably a bit risk averse. Until we understand more, really, I think.
Yeah, I suppose as you get more connections online, it might be that you're tolerating some, but as soon as something else happens somewhere else, that's the
and I think we're already going to have to live with these things, these things, and sort of that's why Insight exists, in terms of we want a monitoring solution that can help manage the risks with them happening, rather than having to just switch anything off that has the potential to oscillate. And the other thing is that one tool would be to detect oscillations and react to that, providing damping solutions. Another approach, which I think a bit more fundamental, would be to sort of measure some sort of stability margin by having different measurement tools that can sort of see how close we are to having something going oscillating, and that might be more useful for operators to sort of preempt and alter the system operation appropriately. Yeah.
One of the other questions here is simply, is one of the conclusions that you have that current network models are not able to help pinpoint the source of such oscillations?
Well, I think the models themselves are useful and do provide insight. I'm sure Kevin could give more information on that. But I think part of the issue is to sort of understand the exact causes of the oscillations. We want to build a testbed model which is kind of open, where we've got generic models rather than supplier models which are all black boxed. So we can really pull apart what's going on inside the different devices to see what control loop or algorithm is oscillating with what else that's happening on the grid. So I think our approach is to develop a test bed with open models, and so we can really get to grip with what's going on inside. But Kevin might be able to expand on that.
No, I think you answered it pretty well.
Yeah.
Like you said, generic models, so that we have an idea of the inner workings of them, to be able to sort of replicate in a more informed way to pinpoint the cause of the oscillation.
But certainly when we have IP protected models for the real network, for real devices that are connected, it does provide additional level of challenge. But I think models, can be sufficient, but models are complex and difficult to manage. So ideally, if we had a better monitoring system, we could perhaps make more informed choices once things are connected.
Yeah, got it. We'll have to wrap up there, but there was one more question just asking if you could expand on what the outputs and findings from work packages 1 and 2 were. So perhaps if you could just drop into the Q&A box and maybe give a few bullet points or links to wherever any reports or outputs from those work packages might be. That'd be great. But thank you very much for your time and the presentation. Good luck with the next phase of work, and we'll move on to NIMBUS.
Thanks, David.
Over to you, Adnan, Gaia, and Chris.
Okay. Hello, good morning. My name is Adnan Mahmood. I'm the project manager from SSEN SIF Session on the NIMBUS project, and I am joined by Gaia Mikic, Chris Poynton, and Andy Turner should also be here representing the project team. Can we move on to the next slide, please? I can skip ahead of this one as well and move on to, here we go. So just about why we're looking at a project like NIMBUS, and it's probably the same sentiment shared across many of the projects that are presenting today. extreme weather is becoming a real problem for network assets if it isn't already. Particularly over the last couple of years, we're seeing quite a lot of cases, and this is more particular to the SSEN transmission network in the north of Scotland, but various types of extreme weather. And the prediction is that they're looking to extend both in duration and intensity of the weather extremes that we're actually experiencing today. We're seeing wildfires, storm and flooding, and extreme cold weathers as well. All in the north of Scotland, which you probably wouldn't think in general would happen. Our own network for transmission in north of Scotland extends over, quite a large degree of terrain. Apologies for the background noise. I've got a 4-year-old running around. And the network requires resilience for over 40 to 60 years across this terrain, as challenging as it is. The current design and models that we use basic locational data, and they generically model the weather effects on assets at a regional level or at a circuit level. And the data that we use, particularly the weather data, is often limited in the granularity to sort of 2-kilometre grid forecasts at a height of 10 metres. And it's generalised and smoothed out. So improved predictive models enable to be able to anticipate these extreme weather events and also the impact of weather events across the asset base is something that is, I think, sorely needed going forward, not just for transmission network assets, but across the board in this sector and, most likely in other sectors as well. Next slide, please. Within the discovery phase, we managed, and the discovery phase for this project happened in discovery round 1, and then we're in round 2. But we managed to select a business-driven use case, which I'll touch upon in the next slide, which we could test within SSE and has potential applicability across the energy sector. Colleagues at Icebreaker 1 did quite a lot of research to identify data sources and data sets and how available and accessible they were, and also held interviews with more than 50 participants to understand what challenges the sector faced, with weather impacts on their asset base. And with the CBA that was done at the time, we managed to quantify a net NPV reduction of around 4% when compared with the baseline approach. The baseline approach being just a standardized asset management, everything is picked with the same brush, looking at it from a certain point of time perspective approach, moving to a risk-based approach where you only monitor or assess an asset where the risk is going to become higher or lower depending on what you want to do. That equated to around 4 million saving over the lifetime of the asset. Pulling those outputs into the alpha phase, the benefits that we saw were the economic side, where we could lower the penalty costs from having network downtime if we could better manage asset risk and therefore, when an asset would fail. Improve resilience. If we're improving the accuracy of the grid-wide risk scoring within those risk models that we've got, we could then focus on how we can make assets last longer and make them more resilient to external factors such as weather. And then also the environmental impact of accelerating the transition to net zero by being able to prolong asset life where we know that the assets are much lower risk of environmental impact, and enhancing the reliability and optimizing the network in that regard as well. Next slide, please. And the use case selected within at the end of the discovery phase that we used within the alpha phase was the 132 kilowatt Beauly to Shin transmission line in the north of Scotland. Now this was selected because of the variety of weather parameters that it experiences, and we thought it would be a good use case to use for this project where we're focusing on weather parameters. Now, the use case would focus on asset degradation over time instead of just when the asset would occur. And we're also looking at within the alpha phase, we looked at general weather impacts, although we're talking about extreme weather impacts as well. We decided to focus on general weather impacts to at least help the asset base in the short term and in some of our decision making in the short term instead of just very specific scenarios in the long term. And we're also, where we tried to look at assets as a whole for the project, we focused on certain components where we know we had the failure data, but overall the tool would look to build degradation of an asset as a whole based on an amalgamation of, I guess, component scores. And one of the main focuses of NIMBUS, which the colleagues at Icebreaker 1 are leading, is sort of taking that user needs and data governance first approach to create a blueprint for the wider industry and other sectors, and to be able to actually effectively share data and make it more accessible where it can be. Next slide, please. Right, I guess I'll hand over to Andy Turner from Palantir, who can take us through some of the proof of concept build. Oh, skipped ahead a few slides there.
Yeah, just go back if you, yeah, that'd be great. Yeah, if you go one more.
One more going forward. And one more again. There we go.
Thanks. So this was the POC build. We took together the sort of information inputs, whether that was the asset management or the weather. And if you go forward one slide, we'll show you what we. Okay. So yeah, we took these information inputs, and what we did was we built out the ability to essentially put all of this onto a single view to visualize condition and weather impacts on a tower by tower basis. So one of the real questions running through this at a high level was, if we had zero asset information, could we use the weather to predict the areas that would have climate impact as opposed to those which couldn't? And yeah, we proved that we could. We saw extremely high correlation between what the weather was telling us and the condition of certain components on certain assets. So that was pretty much proved out. We sort of went beyond that and gave the ability to sort of construct these rules that where another theme of the proof of concept was taking the sort of tribal knowledge of everyone involved, really. Things like, for instance, we think perpendicular winds coming from the sea would have greater impact than those that wouldn't, for instance, as an example of tribal knowledge. So we constructed those rules in the tool, ran them against the sort of weather and the asset condition data, and proved the link between them. So we were able to sort of essentially digest that tribal knowledge into specific rules to make that analyses consistent across the various assets. And then together with some sort of AI and ML, we were able to come up with a recommendation engine, essentially on a per tower basis, that suggested which of these rules or rules that we hadn't even built, actually, in some cases, were having an impact on the towers. If we go to the next slide. So this is just an example of the integration. We have some Excel data, we had some condition data, some IBM weather data that was very, very good, and integrated those into the system. Next slide. And then we constructed an ontology. Basically, for those on the call not familiar with that term, essentially it's linking all of the data together in a kind of a graph ML type of graph database kind of way, which sort of is a new way of looking at things, really. And I think it was very, very successful, the kind of understanding that various different departments had on the same data. So a bottom right hand corner would be your network data, the logical connection of assets to circuits, etc. And then the asset management view on the top right, which was the what connects to what and what actually makes up the tower, in inverted commas. And then layering on top of that, you can see that, you know, some of them are blue and green, which was signify a good condition, and the bracings, you know, are in red. So in immediate kind of recognition that actually we've got some components of that specific tower that need looking at. And then the linkages to that, you know, as you can see on the weather, you know, those were the sort of 15 alerts, weather alerts that we had that actually spoke to the conditions of that bracing. So we were able to link together across multiple data sets, you know, the cause and effect, and then obviously moving on down to the inspections allows an operator to look at, you know, the historical inspections for that component, that asset, and then also look forward to see, you know, how many years will it be until the next inspection. And then, you know, try and determine whether that is sufficient or not. You know, at the same time being cognizant of the existing work orders or existing faults on that particular asset. So the ontology really brought all of the information and all the context together. If we go to the next slide. This is just sort of showing you what we brought together into this picture of the asset. So, you know, all of those things you saw there, the sort of inspection condition of the asset, any maintenance, planned work orders, weather, etc., all into this Asset 360, which is then used to then look at a risk model, you know, that was able to look at, you know, a huge variety of parameters to essentially give that scoring to suggest that actually, if we're seeing a lot of weather alerts, if we're seeing, you know, condition of components that are as a result of that weather, and if that condition is sort of sufficiently high, then it would suggest that we want to take action and bring forward inspections on that asset. And conversely, if we're not seeing any weather alerts, if we're not seeing any sort of particularly bad specific components that make up that asset as a whole, if things look pretty good, then do you know what? It might be a case to reassess the closeness of that inspection date, maybe push it out a bit. And then that's the sort of you know, the sort of high level of the modeling on this particular project. But essentially, I think we were probably we automatically created about 5 models for every tower on the 210 tower line. A lot of models, but seeing as they were automatically created, gave us the outputs that were really, really specific on a per asset basis. If you go to the next slide. And then the last bit was the creation of the sort of UIs and the applications that not only assess the weather risk score on the left-hand side, you can see there the line overlaid with greens, as in, you know, we should probably push these inspections back. Specific areas of red, you know, signifying, you know, we might want to take a look at those areas of higher risk, and the yellows, you know, may or may not take action on those. And that was brought together so that someone could literally assess, you know, the recommended inspection priority, at the same time as looking at what's being suggested on the cyclical rates, and decide whether to essentially enact a risk-based approach to that asset or not. Yeah, next slide. Oh yeah, and there you go. That was the sort of overview of the POC. Happy to take questions at the end or whatever. Have I missed anything, Adnan, that you want us to focus on? Happiness? Okay, great. Over to Icebreaker, I think.
Great, thank you so much. So as Adnan mentioned at the start, Icebreaker 1's focus was looking at data accessibility and interoperability. So based on our work, we identified 8 additional weather data sets with the potential to support the NIMBUS use case. And we evaluated these for their suitability, their relevance, and their openness. And we prioritized the identification of openly published data sets. Based on this, we then indexed any that were appropriately licensed with open data licenses onto the Open Net Zero search engine. But there were 4 key findings from this work package, and then we make 5 recommendations, which I'll talk about on the next slide. So our 4 key findings were actually that there is a lack of openly published weather data sets that is suitable to support the NIMBUS priority use case. Second one was around challenges, that there are challenges to publishing energy asset data, which suggest that the sector would benefit from developing a consistent approach to shared data exchange. Finding 3 focused on there being an issue around data discovery. So there is an absence of openly published metadata, which we would encourage the industry to focus on. And then finding 4 is that increasing data accessibility is complex and it requires multi-stakeholder involvement across technical, regulatory, and organizational domains. If we could go to the next slide, please, I will talk through our recommendations off the back of these. So we actually ran advisory groups to get to be able to focus on work for the sector and with the sector. And so we held 3 different advisory group sessions over the course of the alpha phase. We worked with our advisory group members who were made up of representatives from across the energy industry to basically put together these 5 recommendations. So the first recommendation is actually around aligning industry-wide definitions. We recommend that the ESA must take the lead on urgently aligning industry-wide definitions of key concepts for climate and weather-related asset risk in order to ensure policy, investment, and operations are aligned. Our second recommendation is to align with existing data triage processes. We recommend that Ofgem, in collaboration with the energy sector, must continue to align the existing data triage processes to a shared framework. And one of the recommendations we make is to Icebreaker 1's data sensitivity classes. Recommendation 3 is to co-create standards for energy asset data. We recommend that the Energy Networks Association, the ENA, facilitate the co-design and co-creation of standards for energy asset data to unlock further innovation and reduce bottlenecks across the energy sector. Recommendation 4 is to establish cross-sector engagement for risk and resilience. So the government, potentially via the National Infrastructure Commission, should establish and appropriately resource processes to facilitate continued cross-sector engagement on matters of asset management. And for recommendation 5, we really encourage the direct engagement with end users of data. So we encourage transmission system operators, transmission owners, and distribution network operators to regularly invest in engagement directly with the end users of their data to gather their feedback and suggestions for improved data sharing. I believe at this point I pass back to Adnan.
Yes, next slide, please. Yeah, and I think I'll just quickly summarize the next 2 slides, but we did do an updated CBA for this phase of the project. The new value would be a 5.66 million saving over the lifetime of the, I guess, not just the asset, but the transmission line. And on the right-hand side, you can see where that breakdown comes from. The overall potential benefits is quite similar to before, is that we've got the reduced unplanned outages targeting, I guess in this case, we looked at a specific scenario of a conductor assessment, and we could take a more precise approach to how we can conduct some of these assessments, not just on conductors, but other components as well. And one of the strengths that we would have liked to explore further in the alpha phase and potentially a beta phase is the improved route planning. We did some work with Palantir, who were able to sort of expand on the proof of concept and use it for a scenario where we could plan routes based on the risk scores that the weather data could give. So it could help us better locate assets in the future if we needed to as well. Moving on to the next slide, please. And just in terms of what was next, we've completed discovery and the alpha phase, and then moving into if we were to move into the beta phase, it would be expanding on everything that we've done in terms of the proof of concept and do a sort of a phased approach into ingesting data across the whole of the SSEN transmission network, and build upon some of the architecture that's already been developed by the engineers at Palantir. But also look to develop the sector guidelines for best practice, should I say, for data interoperability and what the regulatory considerations look like as well, as Gay has mentioned before. So that's quite a key aspect of a project like this and many other projects that sit within this remit, is that the data and being able to access it and share it in an efficient and open way is key to be able to then look at things like cross-sector utilization and work with other network operators across transmission and distribution as well. And hopefully that will lead to business as usual. But I guess I can say at this point that the project won't be moving in. I don't know if there's moving on to the next slide, if there is one more slide. No, well, I could say at this point the project won't be proceeding with a beta phase application. Over the alpha phase, there was quite a lot of challenges in actually being able to pull together data for one line The process is still currently quite manual and resource heavy, and currently the business just can't commit to pulling all that resource just for the whole of the network as well. So at this point, we're pausing the project and we'll decide in the future how this progresses and continues, or if it picks up in another funding mechanism. That is our presentation. Apologies for running over.
Brilliant. Thank you very much. Gair, it sounds like maybe that's the case for operationalizing standard processing of data and publication. But maybe that's an aside conversation. Simon, have you got a question you'd like to come in?
Thanks. I was really interested in this one because some of the things you mentioned and spoke about around the data side is exactly what we've seen from the cyber-physical world. And it also mirrors some of the challenges around interoperability of data in the transport sector. Would be interested to find out if the competition I mentioned earlier could be of use, because this challenge of the ontologies and the lack of kind of unified ontologies across different sectors is really hitting a lot of projects and programs now, especially things like the AI programs. So yeah, it's really good to see some real world use cases where you've hit these kind of barriers and found ways to solve them. But would be interested to find out a little bit more about it.
Simon, just off, because I joined a bit later, what was the competition that you'd mentioned previously?
It's called Digital Twin Energy Grids, and it's on the Innovate UK webpage at the moment. And it's it's worth mentioning it's outside of SIF, so the funding's coming from a different route. So okay. it might be of use. Yeah.
Perhaps there may be one to look at separately and follow up on. I do have one other question around how you validate some of the modeling assumptions using historical data. So for instance, if you were to use some of the techniques you developed for routing, how do you validate your assumptions that actually that is going to have the resilience that you expect on a novel route which hasn't been built, and you're tied into that for a multi-decade lifespan?
I think we'd have to take an approach maybe similar to what a project like Predict for Resilience is doing now in the beta phase, is that they're going into sort of a multi-year phase where they're running the system, but also then verifying with the experts and the SMEs who know the actual, who've got all the knowledge built up in their heads or various processes within SSE to then feed back into the system and say, that looks correct, that doesn't look correct, this is maybe what we need to change across the board. Right now, how to verify it completely for something that doesn't exist is probably, I'm not quite sure how they do route planning, but we need to bring in those SMEs to help then, one, set the rules and the parameters that Palantir would need to build into the platform to give us maybe what a good result would look like, and for then the SMEs to then feed back and say, well, as I said, expected output and how have we got to that? You know, are the rules that they've set and the parameters they've set correct? And that wouldn't just be a do it once or do it twice thing. You know, you'd have to do it over, quite a period of time and probably multiple years before people are satisfied the tool is actually producing the output and that we've iterated enough to get to a point where that could actually feed into the decisions that we're making. It'd almost have to run in parallel, I'd say.
Yeah, got it. That makes sense.
I don't know if Andy, unless we run out of time, I don't know if Andy wants to input into that as well.
No, go on, Andy.
Yeah, no, just a very quick one. I think there are very significant route planning pieces of software and processes that already exist, right? And that we wouldn't be seeking to rebuild any of that. It's just an added layer of info that would give literally, and you think of it as an added layer on a GIS or an added input into the decision making to say, if you haven't considered this area, or if you didn't know this area was susceptible to enhanced climate risk based on these different business rules, business models, or indeed weather sort of alerting rules, then here's an additional input. That's all we would sort of layer on top of that, if that makes sense.
Yeah, I think it was more over the validation of whether those rules that you've developed actually manifest themselves in the real world in the way that's expected.
Yeah, I think there's an interim step between no validation and physical proof over many years. I think the interim step is that one where you take a certain line, like we did in NIMBUS. You don't give us condition data at all. Mm-hmm. We run the weather rules and predict with zero knowledge, and then if it lines up with an existing line or something like that, then you understand how correlated those things are, and therefore how good your predictions are. Is that going to match up 100% of the time? Absolutely not. But if you've got something that's higher than sort of 85%, which ours certainly was, then it's better than nothing as an input, if that makes sense.
Yeah, I got it. Brilliant. We will wrap up there, but thank you very much for that, and good luck with all the remaining phases of your projects. Just to highlight very quickly that we do have other show and tell webinars happening associated with the Alpha portfolio. So please do come back and have a look at some of the other ones that we've got going over this week around asset efficiency and improvement, unlocking flex for heat decarb, and also supporting a just energy transition this Thursday. We will be editing and making available all the presentations on YouTube, so please do distribute them to any stakeholder groups you think would benefit. And we've got all these ways of staying in touch with the Strategic Innovation Fund, including the newer rounds that we have open at the moment. Round 4 is live, and we'll be opening a call for ideas shortly. The primary place to go is really the newsletter, because that will give intermittent and periodic updates on everything that's happened in regarding the Ofgem Strategic Innovation Fund. But thank you all for joining. One of my observations from today is, although the energy trilemma seems a little bit dated now, we're certainly moving into the phases of the energy transition where we've proved that renewables are economically competitive, and they obviously have extensive carbon saving opportunities. And now the resilience part of the picture, and how do we really ensure that we can deliver a system which stands up to not just the current challenges, but others that might be arising in the future, seems to be becoming far more important. So plenty more opportunities to be doing work, and it's really encouraging to see all of you working on it already. So thank you all very much for joining. Have a good day.